class going. Alrighty, welcome everybody to Chapter 5. We'll jump right in here. So Chapter 5 is how semiconductor devices are made, types of diodes and rectifiers, bipolar and field effect transistors, and RF integrated circuits, digital logic basics and families, optoelectronics and solar cells and optocouplers. 3 sections, only 62 questions tonight, so not as bad as some of the other nights. So the first section 5.1 is semiconductors. Which of the following semiconductor materials contain excess free electrons? A, the N-type, B, the P-type, C, bipolar, or D, insulated gate?
P, I think.
A.
Alpha is correct.
Oh,
N-type.
okay.
What is the name given to an impurity atom that adds holes to a semiconductor crystal structure? A, insulator impurity, B, N-type impurity, C, acceptor impurity, or D, donor impurity?
Charlie.
Charlie is the correct answer, acceptor impurity. And we'll cover junction diodes. Why does a PN junction diode not conduct current when reverse biased? A, only P-type semiconductor materials can conduct current. B, only N-type semiconductor material conduct current. C, holes in the P-type material and electrons in the N-type material are separated by the applied voltage, widening the depletion region. Or D, excess holes in the P-type material combine with electrons in N-type material, converting the entire diode into an insulator.
C.
C, Charlie.
Charlie is correct. What is the failure mechanism when a junction diode fails due to excessive current? A, excessive inverse voltage, B, excessive junction temperature, C, insufficient forward voltage, or D, charge carrier depletion?
Bravo.
E.
Bravo.
Bravo is correct, excessive junction temperature. Now we'll go over Schottky barrier diodes. And a little heads up, one of these questions is confusing, and so they've decided to pull it from the test pool. Or actually, it's not pulled, it's just not, how is the term we use? Withdrawn from the pool. It's still there, but they're not putting it in the tests.
And which one is that, Jim? I'm sorry.
We'll see it in just a second.
Oh, okay,
It's
okay.
06.
Okay.
What is an important characteristic of a Schottky diode as compared to an ordinary silicon diode when used as a power supply rectifier? A. Delta is correct. Less forward voltage drop. And this is the one that is withdrawn from the question pool. So the other, what was it, a week ago, Daniel received an email and from his VEC group and gave me some updates, and this one is one of the 2 questions that was withdrawn from the question pool. The other, I forgot what section it is, but I marked it up in the,
Why was this withdrawn? A is the correct answer. So
they thought that it was too confusing.
well, it's not confusing. The other ones are just like way out in left field. So
I've got the extra class license manual supplemental information from the
Mhm.
ARRL website. And
Yep.
they said that it was withdrawn because it has two correct answers, A and D.
Okay.
Ah,
Thanks, LJ.
constant voltage reference?
No problem.
mhm.
Yep.
In my book actually says it's withdrawn.
Good.
Okay.
So just for reference, in the book, double check Echo 1 Charlie 05, E1C05 was the other one that they pulled. And I actually should just check here in the back and see if it says withdrawn. E1C, because Daniel said that was the other one that was withdrawn, E1C05. Oh, it doesn't say anything in the back, but I'm going to mark it.
What number was that again? E1C05?
Yes, Echo 1 Charlie 05 is the other one. And then there's a third update that was, this one was completely deleted from the pool. It's Echo 3 Bravo 08. Echo. I updated it in my slide deck, but I didn't update it in the book. Oh, yeah. And in the back of the book in the question pool, page 13-29, it does say question has been withdrawn. So those are the updates, and thanks again, LJ, for the rest of the story.
That other one was
Yeah, no worries.
that other one was Echo 1 Charlie 05. That one's gone?
Correct. Yeah, and that one, if I pull it up on the slide deck, I'll print across like I did on this one, withdrawn from the question pool. Alrighty, let's move on. Which of the following is a Schottky barrier diode? A, metal semiconductor junction. B, electrolytic rectifier. C, pin junction. Or D, thermionic emission diode.
A.
A is correct. Metal semiconductor junction. What is a common use for point contact diodes? A, as a constant current source. B, as a constant voltage source. C, as an RF detector. Or D, as a high voltage rectifier. The correct answer is Charlie, is an RF detector. Okay, just one Zener diode question. What is the most useful characteristic of a Zener diode? A, constant current drop under conditions of varying voltage. B, a constant voltage drop under current a constant voltage drop under conditions of varying current. Or C, a negative resistant region. Or D, an internal capacitance that varies with the applied voltage.
Bravo.
Bravo.
E.
Bravo is correct. A constant voltage drop under conditions of varying current. One varactor diode question. What type of semiconductor device is designed for use as a voltage-controlled capacitor? A varactor diode. B, a tunnel diode, C, silicon controlled rectifier, or D, Zener diode?
Delta.
Alpha
A.
is correct, varactor diode. 2 pin diode questions. What characteristic of a pin diode makes it useful as an RF switch? A, extremely high reverse breakdown voltage. B, ability to dissipate large amounts of power. C, reverse bias controls its forward voltage drop. Or D, low junction capacitance.
Delta.
Delta is the correct answer, low junction capacitance. What is used to control the attenuation of RF signals by a pin diode? A, forward DC bias current. B, a subharmonic pump signal. C, reverse voltage larger than the RF signal. Or D, capacitance of an RF coupling capacitor.
A alpha.
A alpha is correct, forward DC bias current. 2 LED questions. What type of bias is required for an LED to emit light? A, reverse bias. B, forward bias. C, zero bias. Or D, inductive bias.
Bravo.
Bravo is correct, forward bias. In figure E6-2, what is the schematic symbol for a light emitting diode? A, number 1, B, number 5, C, number 6, or D, number 7?
B.
Bravo is correct, number 5. 3 bipolar transistor questions. What is the beta of a bipolar junction transistor? A, the frequency at which the current gain is reduced to 0.707. B, the change in collector current with respect to the base current. C, the breakdown voltage of the base to collector junction. Or D, the switching speed. Bravo is the correct answer. The change in collector current with respect to base current. Which of the following indicates that a silicon NPN junction transistor is biased on? A, base to emitter resistance of approximately 6 to 7 ohms. B, base to emitter resistance of approximately 0.06 to 0.07 ohms. C, base to emitter voltage of approximately 6 to 7 volts. Or D, base to emitter voltage of approximately 0.6 to 0.7 volts.
Delta.
Delta is correct. What term indicates the frequency at which the grounded base current gain of a transistor has decreased to 0.7 of the gain obtainable at 1 kilohertz? A, the corner frequency. B, alpha rejection frequency. C, beta cutoff frequency. Or D, alpha cutoff frequency. Blah. The correct answer is delta, alpha cutoff frequency. 5 field effect transistor questions. How does DC input impedance at the gate of a field effect transistor compare with the DC input impedance of a bipolar transistor? A, they are both low impedance. B, an FET has lower input impedance. Or C, an FET has higher input impedance, or D, they are both high impedance?
Charlie.
Charlie is correct, and FET has higher impedance, input impedance. What is a depletion mode FET? A, an FET that exhibits a current flow between source and drain when no gate voltage is applied. B, an FET that has no current flow between source and drain when no gate voltage is applied. C, an FET without a channel. Or D, an FET for which holes are the majority carriers.
A.
Correct answer is A. An FET that exhibits current flow between the source and drain when no gate voltage is applied. In figure E6-1, what is the schematic symbol for an N-channel dual gate MOSFET? A, number 2, B, number 4, C, number 5, or D, number 6? Dual gate N-channel. Correct answer is Bravo, number 4. Yep. In figure 6-1, what is the schematic symbol for a P-channel junction FET? A, number 1, B, number 2, C, number 3, or D, number 6?
A.
Alpha is the correct answer.
006 Whiskey Victor India.
Hey, Joe, can you,
Yeah,
okay, we can
I'm
hear
sorry.
you. Why do many MOSFET devices have internally connected Zener diodes on the gates? A, to provide a voltage reference for the correct amount of reverse bias gate voltage. B, to protect the substrate from excess voltages. C, to keep the gate voltage within specifications and prevent the device from overheating. Or D, to reduce the chance of static damage to the gate.
Delta.
Alpha.
Delta is the correct answer, to reduce the chance of static damage to the gate. 9 questions on RF integrated devices. What is a microstrip? A, lightweight transmission line made of common zip cord. B, miniature coax used for low power applications. C, short lengths of coax mounted on printed circuit boards to minimize time delay between microwave circuits. Or D, precision printed conductors above a ground plane that provide constant impedance interconnects at microwave frequencies.
Delta.
Delta is correct.
Glad I don't have to write that out.
Yeah, whoops. I meant to do this one. Yeah, so this one, the longest answer is the correct one. Wow. In what application is gallium arsenide used as a semiconductor material? A, in high current rectifier circuits. B, in high power audio circuits. C, in microwave circuits. Or D, in very low frequency RF circuits.
Charlie.
Charlie is the correct answer, in microwave circuits. Okay, hang on real quick. I need to send another email for the correct meeting. Somehow people are getting the old meeting. Oops. And that was Elizabeth. Okay. Hopefully she gets that. Okay, next question. Why is gallium arsenide GaAs useful for semiconductor devices operating at UHF and higher frequencies? A. Higher noise figures. B. Higher electron mobility. C. Lower junction voltage drop. Or D. Lower transconductance.
Bravo.
B.
Bravo is correct. Higher electron mobility. Which of the following materials is likely to provide the highest frequency of operation when used in MMICs? A. Silicon. B. Silicon nitride. C. Silicon dioxide. Or D. Gallium nitride.
D.
Delta.
Delta is correct. Gallium nitride. Never knew I was going to learn so much about chemicals. Or
I think it's gallium.
gallium.
Isn't that from Doctor Who?
Which
Sorry, never mind.
Which is the most common input and output impedance of circuits that use MMICs? A. 50 ohms. B. 300 ohms. C. 450 ohms. Or D. 10 ohms.
Alpha.
Alpha is correct. 50 ohms. Which of the following noise figure values is typical of a low noise UHF preamplifier? A. 2 dB. B. Negative 10 dB. C. 44 dBm. Or D. Minus 20 dBm.
Alpha.
Alpha.
Alpha is correct. 2 dB. What characteristics of MMIC make it popular choice for VHF through microwave circuits? A. The ability to retrieve information from a single signal even in the presence of other strong signals. B. Plate current that is controlled by a control grid. C. Nearly infinite gain, very high input impedance, and very low output impedance. D. Controlled gain, low noise figure, and constant input and output impedance over the specified frequency range.
Delta.
Delta is correct.
They'd have to
Long
glow in
answer.
the dark for the other one.
What was that, Mark?
They'd have to glow in the dark for B.
Oh, yeah. Had to toss a tube in there. What type of transmission line is used for connections to MMICs? A. A miniature coax. B. A circular waveguide. C. Parallel wire. Or D. Microstrip.
Delta.
Delta.
Delta is correct, the microstrip. How is power supplied to the most common type of MMIC? A. Through a resistor and or RF choke connected to the amplifier output lead. B. MMICs require no operating bias. Or C. Through a capacitor and RF choke connected to the amplifier input lead. Or D. Directly to the bias voltage VCC in lead.
Alpha.
Bravo.
Alpha is the
Yeah.
correct answer. Through a resistor and or choke connected to the amplifier output lead.
It's 7:30.
Thank you. What's the temperature? Alexa, what's the temperature? 11 optoelectronics. Oh, and my Alexa just answered. What absorbs
Mine too.
Google? What? No, sorry.
What's the temperature? Jim?
What absorbs the energy from light falling on a photovoltaic cell? A. Protons. B. Photons. C. Electrons. Or D. Holes.
Charlie.
Charlie.
Charlie is correct. Electrons. Okay. Stop that pop-up. What happens to the conductivity of a photoconductive material when light shines on it? A. It increases. B. It decreases. C. It stays the same. Or D. It becomes unstable.
Alpha.
Alpha is correct. It increases. What is the most common configuration of an optoisolator or optocoupler? A. A lens and a photomultiplier. B. A frequency modulated helium neon laser. Or C. An amplitude modulated helium neon laser. Or D. An LED and a phototransistor.
Delta.
Delta.
Delta is correct. Bless you.
Thank you.
What is the photovoltaic effect? A. The conversion of voltage to current when exposed to light. B. The conversion of light to electrical energy. C. The conversion of electrical energy to mechanical energy. D. The tendency of a battery to discharge when exposed to light.
Bravo.
Bravo.
Bravo is correct. The conversion of light to electrical energy. Which describes an optical shaft encoder? A. A device that detects rotation of a control by interrupting a light source with a patterned wheel. B. A device that measures the strength of a beam of light using analog to digital conversion. C. A digital encryption device often used to encrypt spacecraft control signals. Or D. A device for generating RIDI signals by means of a rotating light source.
Alpha.
Alpha.
Alpha is correct. Which of these materials is most commonly used to create photoconductive devices? A. A crystalline semiconductor. B. An ordinary metal. C. A heavy metal. Or D. A liquid semiconductor.
Alpha.
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 Alpha is correct. A crystalline semiconductor. Which is a solid-state relay? A. A relay using transistors to drive the relay coil. B. A device that uses semiconductors to implement the functions of an electromechanical relay. C. A mechanical relay that latches in the on or off state each time it is pulsed. Or D. A semiconductor passive delay line.
Bravo.
Bravo is the correct answer. Why are optoisolators often used in conjunction with solid-state circuits when switching 120 volts AC? A. Optoisolators provide a low impedance link between a control circuit and a power circuit. B. Optoisolators provide impedance matching between control circuit and power circuit. C. Optoisolators provide a very high degree of electrical isolation between a control circuit and the circuit being switched. Or D. Optoisolators eliminate the effects of reflected light in the control circuit.
Charlie.
Charlie.
Charlie is correct. The longest answer again. What is the efficiency of a photovoltaic cell? A, the output RF power divided by the input DC power. B, cost per kilowatt hour generated. C, the open circuit voltage divided by the short circuit current under full illumination. Or D, the relative fraction of light that is converted to current.
Delta.
Delta.
Delta is correct. The relative
It's not the
fraction of
longest answer, though.
not the longest answer this time.
I was going to say C.
I don't know how you'd ever measure the short circuit current.
Yep. What is the most common type of photovoltaic cell used for electrical power generation? A, selenium. B, silicon. C, cadmium sulfide. Or D, copper oxide.
E.
Charlie.
Bravo.
Bravo is the correct answer, silicon.
Silliest one.
What is the approximate open circuit voltage produced by a fully illuminated silicon photovoltaic cell? A, 0.1 volt. B, 0.5 volt. C, 1.5 volt. Or D, 12 volt.
Bravo.
Bravo is correct. 0.5 volts. 5.3, digital logic. And boy, are we going to have fun with this one. Number 9 questions. What is tri-state logic? A, logic devices with 0, 1, and high impedance output states. B, logic devices that utilize ternary math. I hope that's right. Ternary math, yeah. C, low power logic devices designed to operate at 3 volts. Or D, proprietary logic devices manufactured by Tri-State Devices Incorporated.
Alpha.
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 Alpha. Boy, I like those distractors. In figure E6-3, what is the schematic symbol for a NAND or a negative AND gate? A, number 1, B, number 2, C, number 3, or D, number 4?
Delta.
Negative AND gate.
Oh, Bravo.
Bravo is correct.
Bravo.
And there's the NAND, or the negator, and there's the AND. So, yep. In figure 6-3, what is the schematic symbol for a NOR gate or a negated OR? A, number 1, B, number 2, C, number 3, or D, number 4?
Delta. Delta.
Delta is correct. The OR symbol with the negator on it. In figure 6-3, what is the schematic symbol for the NOT operation or an inverter? A, number 2, B, number 4, C, number 5, or D, number 6?
Charlie.
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 Charlie is correct. The number 5 is the NOT or an inverter. What logical operation does a NAND or a negative AND gate perform? A, it produces logic 0 at its output only when all inputs are logic 0. B, it produces logic 1 at its output only when all inputs are logic 1. Or C, it produces logic 0 at its output if some but not all of its inputs are logic 1. Or D, it produces logic 0 at its output only when all inputs are logic 1. D, delta is the correct answer. Produces logic 0 at its output only when all inputs are logic 1. What logical operation does an OR gate perform? A, it produces logic 1 at its output if any or all inputs are logic 1. B, it produces logic 0 at its output if all inputs are logic 1. C, it only produces logic 0 at its output when all inputs are logic 1. Or D, it produces logic 1 at its output if all inputs are logic 0.
A.
Alpha.
Alpha is correct. Produces logic 1 at its output if any or all inputs are logic 1. What logical operation is performed by an exclusive NOR gate? A, it produces logic 0 at its output only if all inputs are logic 0. B, it produces logic 1 at its output only if all inputs are logic 1. C, it produces logic 0 at its output only if one input is logic 1. Or D, it produces logic 1 at its output if only one input is logic 1. The correct answer is C in this one. It produces a logic 0 at its output if only one input is logic 1.
These are like reverse story problems.
Yep. What is it?
Wasn't that question withdrawn?
I think it was, yes.
What was the question again?
No, that question was another one that's been withdrawn.
Right.
Which one?
The one we just read, A09.
This one,
E7A09.
is that on the list?
It wasn't on the one you gave us, but it was in the book, I think.
Oh, really?
Yeah.
Let me go to that real quick and mark it down because I didn't have that from Daniel. E7 A09. Oh, yeah. Okay, let me add that in here. E7A09 withdrawn. I'll update the slide deck for next round. Thank you. Didn't catch that. Okay, what is a truth table? A table of logic symbols that indicate the high logic states of an op-amp. B, a diagram showing logic states when a digital device output is true. C, a list of inputs and corresponding outputs for a digital device. Or D, a table of logic symbols that indicate the logic states of an op-amp.
E.
Charlie.
Charlie is correct. A list of inputs and corresponding outputs. What type of logic defines 1 as a high voltage? A, reverse logic. B, assertive logic. A, reverse logic. B, assertive logic. C, negative logic. Or D, positive logic.
Delta.
Delta.
Delta is correct, positive logic. All right, 6 questions for sequential and synchronous logic. Which circuit is bistable? A, an AND gate. B, an OR gate. C, a flip-flop. Or D, a bipolar amplifier.
Charlie.
Charlie is correct, a flip-flop. What is the function of a decade counter? A, it produces 1 output pulse for every 10 input pulses. B, it decodes a decimal number for display on a 7-segment LED display. C, it produces 10 output pulses for every input pulse. Or D, it decodes a binary number for display on a 7-segment LED display.
Alpha.
Alpha is correct. It produces 1 output for every 10 input pulses. Which of the following can divide the frequency of a pulse train by 2? A, an XOR gate. B, a flip-flop. C, an OR gate. Or D, a multiplexer.
Bravo.
Bravo is correct, a flip-flop. How many flip-flops are required to divide a signal frequency by 4? A, 1, B, 2, C, 4, or D, 8?
Bravo.
Bravo is correct, 2 flip-flops. Which of the following is a circuit that continuously alternates between 2 states without an external clock? A monostable multivibrator. B, a JK flip-flop. C, a T flip-flop. Or D, an astable multivibrator.
Delta.
Delta is correct, an astable multivibrator. What is a characteristic of a monostable multivibrator? A, it switches momentarily to the opposite binary state and then returns to its original state after a set time. B, it produces a continuous square wave oscillating between 0 and 1. C, it stores 1 bit of data in either a 0 or 1 state. D, it maintains a constant output voltage regardless of variations on the input voltage.
Bravo.
Alpha is the correct answer. It switches momentarily to the opposite binary state and then returns to the original state after a set time. 5 questions in logic families. Which of the following is an advantage of BiCMOS logic? A, it simply results in much less expensive devices than standard CMOS. B, it is immune to electrostatic discharge. C, it has a high impedance of CMOS and the low output impedance of bipolar transistors. Or D, all these choices are correct.
C.
Charlie is the correct answer. It has a high input impedance of CMOS and a low output impedance of a bipolar transistors. What is the advantage of CMOS logic over TTL devices? A, differential output capacity. B, lower distortion. C, immune to damage from static discharge. Or D, lower power consumption.
Charlie.
Delta is the correct answer in this case. CMOS has lower power consumption over TTL. Why do CMOS digital integrated circuits have high immunity to noise on
Hey,
the
Jim,
inputs?
sorry to interrupt you, but that last question was actually at the bottom of 525, not 526. So if you want to make that change next time. Just got that.
This one here?
E6CO5 is at the bottom of 5-25, not 26.
Okay, E6CO5. Thanks. Bottom of 5-25. Okay, I'll update that. Why do CMOS CMOS digital integrated circuits have high immunity to noise on the input signal or power supply? A. Large bypass capacitance is inherent. B. Input switching threshold is about 2 times the power supply voltage. Or C. The input switching threshold is about 1/2 the power supply voltage. Or D. Bandwidth is very limited.
Charlie.
Charlie is correct. The input switching threshold is about 1/2 of the power supply voltage. What best describes a pull-up or a pull-down resistor? A resistor in a keying circuit used to reduce key clicks. B, a resistor connected to the positive or negative supply line used to establish a voltage when an input or output is an open circuit. C, a resistor that ensures that an oscillator frequency does not shift. Or D, a resistor connected to an op-amp output that prevents signals from exceeding the power supply voltage.
Bravo.
Bravo.
Yeah, bravo.
Bravo is correct. What is a programmable logic device, a PLD? A logic circuit that can be modified during use. B, a programmable collection of logic gates and circuits in a single integrated circuit. Or C, programmable equipment used for testing digital logic integrated circuits. Or D, a type of transistors whose gain can be changed by digital logic circuits.
Bravo.
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 Bravo is correct. Dib, 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 dib. That's all, folks. Kind of a short one.
Jim, I
Thanks,
can't
Jim.
call up my picture on the screen. There it is. But I can't pull up like a gallery of pictures.
So if you go on the screen and up to the top right, there should be a Hollywood Squares 3x3 thing that says view. If you click on that, you should see a gallery view. So
Screen view. I don't see anything view.
okay, it's on the main window. When I'm chatting, there's a little window. If you see just me and nobody else, I think the other thing that you may have going is there up at the top there's a border, and if you go over to the far right, it should expand and give you everyone.
Yeah, go full screen.
Yeah, go full screen.
Okay. I'm in full screen. I've got Pam up completely across the screen, and I see myself. I'm trying to find whatever.
You're moving your cursor. Should appear.
Yeah, move your cursor around towards the upper right, and when you're in full screen, there should be a symbol that says view up in the upper right corner. So we ended really quick on this one. Is there any questions on chapter 5?
I noticed, Jim, that a lot of the answers were the long answer this time.
Yep, except for that one.
Yeah. It'll trip you up if you try to use that. But,
Yep. But yeah, you're right. I think tonight Daniel is out. I think he has his meeting tonight, so good thing it was an easy chapter. So
There was-
next, yeah.
There was one section that really threw me for a while because I didn't pick up on the distinction. It's in the on page 520 in the section the exclusive NOR operation. I had a lot of trouble trying to understand it, comparing it to the schematic 5.35 until I realized that I wasn't separating the XOR or not OR and then the exclusive not OR or NOR. And it was like once I got that, it was like, oh, okay. But I found that to be really confusing.
Yeah, and the symbols look very similar, 5.34 and 5.35. The big difference in the exclusive OR is you see that little curved line right on the inputs to designate the exclusive OR.
Right.
And that gives it the when you have the one input, one on both of the inputs, then you get a one on the output.
Yeah.
So any other thoughts or comments on chapter 5? That's real digital. We weren't doing FT8, we were doing real digital tonight. No Pactor, sorry Mark, no Pactor tonight either. Alrighty, if there's nothing else, I'm gonna go ahead and stop the recording and